right. Welcome back to another episode of Learn Networking with IPv Dre. As you can see here, we are going to be exploring basic Eigrp configuration. And the purpose of this little packet tracer lab is to dive deeper into the Eigrp concepts that I learned over the course of my studies for the CCNA. I'm currently preparing for the CCNP, kinda, sort of, and I'm studying for the CCNP Enterprise, which will allow for me to go deeper into everything that I learned during my CCNA studies. So Eigrp wasn't really specified in my CCNA study materials, but it helped a lot to learn when I was studying for the CCNA, and it also helped me to round out my understanding of how routing protocols work and how to compare and contrast between different routing protocols, if you will. So once again, we're going to be getting into some of the weeds of Eigrp, the differences between Eigrp and OSPF, and yeah, let's get going. So we have a little 3-router network here with point-to-point links set up between each router. We have router 1, 2, and 3. And we have a step-by-step list that we are going to adhere to so that I don't get too off track, because I like to ramble a little bit, right? So the first thing we're going to do is we're going to configure loopback addresses for each router, and that's going to essentially ID the router. I mean, we can explicitly configure a router ID on the Eigrp, but we're going to be using loopback addresses. So here we go. Enable conf t, yelling at myself here with the capitals, and we are going to go into interface loopback 0. Right? You can use the interface. You can type it all out if you want. Interface, loopback, and then you could put 0. But we're not going to do all of that, right? And for router 1, it's going to be 1.1.1. Oops, nope. Let's do IP add 1.1.1.1, and it's going to be 255.255.255.255, right? No shut. It's already up, but I like to do that anyway. And then we're gonna go to router 2. Let's name this router 2 so we don't confuse them. Router 2, interface, loopback 0. And it's gonna be 2.2.2.2, 255.255.255.255. Control A because I forgot the IP address command. Made a little boo-boo here. IP add, where's the boo-boo? Okay, the boo-boo's right there. And then let's get out of here. And let's go in here. Let's name this router 3. Interface loopback 0. 3.3.3.3. I can't wait to learn the automation stuff because I imagine that it'll make all of this a lot easier. And I keep forgetting the IP address command. IP address. Okay, so now we have the loopback interfaces, the loopback addresses set up on those interfaces. And now we're gonna start with the fun stuff. We're gonna start configuring Eigrp. So Eigrp stands for Enhanced Interior Gateway Routing Protocol. It's a Cisco proprietary protocol, but I believe recently they made some portions of Eigrp public for industry use, but Cisco still owns it, right? And if you've been studying other routing protocols, Eigrp has an administrative distance of 90, which is lower than OSPF's 110. And that means that any route learned by Eigrp is going to be looked at as more believable than OSPF learned routes. So I might even configure OSPF real quick to show you guys the difference, and even to manipulate the distances a little bit. I don't know. I might do that. I don't know. But let's focus on Eigrp first. So we're going to configure Eigrp on each router and advertise all networks on all interfaces. In Eigrp, the AS numbers must match on each router. This is unlike OSPF, where the process IDs do not have to match. So already we're seeing some differences between Eigrp and OSPF. Eigrp has what's called as an autonomous system number, and OSPF has process ID. So on OSPF, the process IDs doesn't have to match, and on Eigrp, the AS numbers must match. And the syntax looks similar, right? So let's go into router configuration mode, router Eigrp, and we're gonna choose autonomous system number 8888 because that's my favorite number, 8888. I was gonna use AS100, but let's make it AS8888. All right, so router Eigrp. Now the next thing we're gonna do is we're gonna use the network command, and the network command, we can simply put the class address, because Eigrp defaults to classless or class logic. I put, classful logic, and it'll activate on all interfaces. It'll activate Eigrp on all interfaces when we do that, right? So we do network 172.16.0.0, and it'll default to classful logic if we don't use a mask, right? So there we have that network. Also, the loopback network 1.1.1.1, but we're going to use a wildcard mask here to make an exact match to the loopback, right? There we have that. And then also, it's best practice to issue a passive interface command, which is similar to Eigrp, same exact command for Eigrp. And our passive interface is 1.1.1. Nope, it's interface loopback 0, right? Where did I make the error? I think I made an error. Interface loopback, or do I just put L0? Oops, L0. There we go. It's a little later in the afternoon, so getting a little hungry. So the passive interface command allows for us to reserve some router resources, because when we issue this command, it won't propagate any messages out of this interface, right? So we're saving some resources there, saving a little bandwidth there, right? So that's router 1. Now let's do router 2 as well. And this is where all the magic is going to start to happen. And we have the network command, and we're going to use the simple classful network. And as we can see, a new adjacency was formed between these two routers. We have to remember that in order for routers to form neighborships, one of the attributes or requirements is that we are on the same link, right? So that's how we form this adjacency. If you remember from your CCNA studies, 5 means notification in the syslog message. Dual, what's dual? So dual is essentially the algorithm, if you will, that allows for us to use Eigrp. I believe it's an algorithm, for lack of a better term, right? So you're gonna see what that means in a second, right? So we have this new adjacency, and now let's hit up the loopback interface. It's not 1.1.1, it's 2.2.2.2, 0.0.0.0. And then we're going to issue the passive interface command, passive interface L0. And then let's get out of here. Let's skedaddle. So now, router 3, we have router EIGRP. And then now we're going to issue this network command. We can also abbreviate it with the net command 172.16.0.0. And then now we have 2 new adjacencies right here. And I find that to be, that's the beauty about EIGRP. You just put in a classful mask and it'll just activate on both. I mean, you could do the same thing with OSPF. I think I'm just a Cisco fanboy. I'm such a Cisco fanboy. Let's save this because packet tracer, I'm not too much of a fan of though, right? Oh, also, we need to disable auto summary, right? So first and foremost, let's just do a little bit of review. So essentially what we did was we activated the EIGRP process on each router, and then we activated EIGRP on each interface so that each interface's networks will be advertised to other routers, because that's what a dynamic routing protocol does, right? And then you have these adjacencies that's formed. We advertise the loopback. Did we do that here? No, we didn't do that. Let's put net 3.3.3.3 0.0.0.0. Got a little ahead of myself, got a little excited. And then we're gonna do a passive interface loopback 0, right? Now we have to issue auto summary, right? No auto summary, right? So I think EIGRP auto summary is activated by default. What we want to do is we want to disable auto summary. No auto summary. We're going to do that on all of these routers right here. Router EIGRP, and then I was making sure my mic was on just now because it would have been a travesty if my mic wasn't on. Man, oh man. Sometimes I leave it off by mistake. Okay, so no auto summary. No auto summary. And then this is where things get a little bit interesting for me. And this is one of the things that I love about networking. I mean, this stuff can get very complicated. And I don't know. I think it's art, to be honest. It's art, even though people get frustrated with it like myself. So why are we disabling auto summary? Auto summary, I always thought that auto summary, ever since I learned it, or summarizing routes, was a good thing, right? But the problem is when you have like an EIGRP network right here, and then you have multiple subnets that are off each router right here. When you summarize these routers, let's just say that these are in separate subnets right here, right? These are in separate subnets. I forgot to put the colorful stuff over there, right? To illustrate that they're in separate subnets. So all of these networks exist off of these routers. And it's my understanding, and you can correct me if I'm wrong, that when you have auto summary activated on each of these routers, it essentially summarizes all of these subnets, and then it advertises that summary out into a wider network like we see here, which is this 172.16.0.0 network, right? So what that essentially does is it hides the details of each subnet behind this router. And that's a bad thing because, suppose we have more networks over here that's using the class A. We don't use classes anymore, we use CIDR, but since Eigrp is activated and it's using summaries, we can kind of speak in those terms. We have some 10.0 networks over here as well, right? So the problem with that too is it's hiding the details of these subnets behind the summary mask, behind this router, right? So now, suppose a packet for this network is coming from somewhere out here, and these routers are advertising these summary routes, 10.0.0/8. First of all, where does the traffic go? Secondly, I mean, the routers are going to figure out where to send it based off of how it makes forwarding decisions. But there's a huge possibility that it gets sent to the wrong network, right? And we don't want that. So this is why we disable auto summary, to essentially avoid that from happening, and therefore revealing the details of these subnets, right? Because this is VLSM, right? We have essentially, we can, well, it's not variable length subnet mask, but if we have VLSM and this is a /30, this is a /24, 16, whatever it is, right? Whatever weird number, 27, whatever. This auto summary is going to hide all of those details, and some bad things are going to happen, right? So that's why we use auto summary. And I don't know, since we are a little bit ahead on time, I guess I can start looking around in the routing table, right? So we got no auto summary, right? Do show IP route. And we see that, can I stretch this out? Yeah, there we go. We can see that there's some routes learned from other networks via Eigrp, which is under dual, right? As we said before. Here's another thing. These metrics are huge metrics in Eigrp as opposed to OSPF, which is a lot more simpler, straightforward. But we have the administrative distance here as 90, right? We can fool around with that using the distance command. Let's see, router, Eigrp, AS number is 8.8, not 8.8.8.8, 8.8.8.8. I'm used to saying Google's Google server's IP address. So distance, we could fool around with it. Distance, I think that's only for OSPF. So let's do Eigrp, right? Let's do OSPF real quick. Let's configure OSPF. So router, OSPF 1, network. It's gonna activate it on all. 255.255.255.255.255. See, this is me just playing around right now. This is what I love to do. I love to say, what if? I like to experiment a little bit. In my labs though, This is something I'd never do in a production network. So we activated OSPF on every interface on this router. Let's do it here too. Router OSPF. Just basic stuff. We're not even gonna go too far with it. There's many things we could do with OSPF, including making it multi-area. But we're not gonna do that. Area 0. Network. 255.255.255.255. Area 0. Yeah, so they form the neighborship there, form the neighborship there, form the neighborship there. Now we can see, let's see something real quick in the routing table. Do show IP route. So we have OSPF activated, but we have no OSPF routes in the routing table. So it doesn't mean that the router is not learning the routes. It is learning the routes, but it's not putting it into the routing table and using it to make routing decisions at the moment. So I think this is where we can use a distance command, and we can make it smaller, make the administrative distance smaller than the Eigrp's administrative distance. Yep. And then do show IP route. And then now we have OSPF, right? See, this is stuff I like to just play around with every now and again, just to, you know, because I think that's a valuable command to know, because I think many industries are using OSPF. Not really sure. I'm not in the field yet as far as working in the field, but I have to do some research to see. I think a lot of companies are using OSPF, right? I think OSPF is pretty solid. OSPF, and I just learned BGP, the basics of it, the other day, and it was fun to set up. So that's pretty much that, right? We configured Eigrp, we configured OSPF, single area OSPF. We played around with the distance command to manipulate the routing table a little bit. And you can see these metrics are much smaller. They're much smaller, right? And we just had a little fun with it. It's nothing too crazy. We just, you know, played around with some Eigrp so that we can deepen our knowledge a little bit. And that's pretty much it. So I'll talk to you guys next time.